Hi, this is Mrs. Minowitz, and today we're going to be looking at matter and talking about a few things that you might have discussed in 6th and 7th grade and really expanding and extending and going a little bit deeper with some of those things. So we're going to start. You'll want to have your note sheet handy so you can fill that in as we go along. So first of all, matter is anything that takes up space and has mass. Now, space, we measure volume, how much space something takes up. Mass is the amount of matter, how much stuff we have in an object. You measure that with a balance. Pretty much any physical object that you can think of that you can touch is matter. Everything you think of. Yourself, your table, your desk, your pencil, your computer, your phone, all of those are matter. Things that would not be matter would be energy, things like light, heat. These things can travel in waves. They are not matter, but most things that you think of are going to be matter. Now there are, if you look up and you research how many states of matter, you might have heard 3, you might have heard 4, you might see 4, 5, 6. We're going to look at some of the different states or phases of matter. Pretty common, solid, liquid, and gas. Then there's also a fourth one that is called plasma. Plasma is superheated or electrically charged gas. This is found in stars and lightning. If you look up in the sky, 99% of the visible universe is actually made out of plasma. So even though we don't talk about it as much as solid, liquid, and gas, it is definitely there. There are also some other forms of matter that you won't hear very often. One is the Bose-Einstein condensate. This only occurs in extremely cold temperatures, very close to what's called absolute zero, as cold as it can possibly get. And then the other one is what's called neutron degenerate matter. This only occurs in matter that is very, very dense or very, very compacted together. And this would be in what are called neutron stars that we're going to talk about in our astronomy unit in probably January, February. You can move between the different states of matter, okay? Freezing, melting, condensing, things like that. And to do that, to move from one state of matter to the next requires energy in the form of heat. Okay? Requires energy to move between one state of matter to the other. You do not have to go directly in this order, though. There is another process here. For example, you can go directly from a solid to a gas, and that is called sublimation, and that completely skips the liquid phase. We're actually going to see sublimation in lab that we do in a couple of weeks. But these are our different states of matter and how you move between them. All of our matter is made up of atoms. Atoms are the building blocks of matter. Everything that you can think of with its matter is made up of atoms. Okay? Books, pencils, pens, desks, all of those things are made up of atoms. There are 3 different parts of the atom that we're going to talk about. Okay? And those 3 parts are called the proton, the neutron, and the electron. Protons have a mass of 1. They have a positive charge, and they are found in the nucleus or the center of an atom. Another particle is the neutron. It has a mass of 1, but it has 0 charge. This makes sense if you think of the word neutral, right? Something that's not on either side. This one is neither positive nor negative, and it is again found in the nucleus. Electrons are much, 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 much smaller and have much less mass than protons and neutrons. So they have what scientists say is a mass of 0. Technically it still exists, but it's so small that compared to the others that it really doesn't count. It has a negative charge, and electrons are found outside of the nucleus in what are called electron clouds or electron shells or electron rings. You'll hear all of those terms. Now, this picture shows a picture of a carbon atom, and this is the atomic structure of carbon. In the center, in the nucleus, okay, we have 6 protons. They have a positive charge. The nucleus also has 6 neutrons, and we'll look at how to figure out exactly how many neutrons an atom has. Those are both in the center in the nucleus. On the outside, though, however, we have the electrons. And if you look here, in this first shell, okay, there are 2 electrons. The most that first shell can hold is 2 electrons. And in the outer shell for carbon, 1, 2, 3, 4, there are 6, or excuse me, there are 4 electrons, total of 6 electrons. That outer shell can actually hold up to 8, but the ones that didn't fit in the first shell go in the second one. So if you look at this, we've got 6 positives, 6 negatives. Overall, that equals no overall charge. And we're going to look at how to draw the atomic structure for some different elements and atoms when in class. To kind of put this in perspective as far as size is concerned, 1 unit of measurement for atoms is the angstrom. And the angstrom is 1/10,000,000th of a meter. And the one, you would have to have 10 billion angstroms to come up with a meter, and a hydrogen atom is about 1 angstrom across. So they're very, very small. You could have 1,000,000 atoms on the tip of your pencil. That's approximately how many atoms are on the tip of your pencil. It's a lot. Now, matter can be divided into different groups. Okay? And one of the ways we're going to do that is we're going to look at what are called elements. Okay? Elements are matter that contain only one kind of atom. Okay? This is fairly rare, and we will look at the periodic table of the elements and talk more about that in class. And when you look on that, you'll see that there are 118 elements. Now, being the smart 8th graders that you are, you realize that there are way more than 118 things that exist in the world. Things are made out of more than 118 things. So there are also things called molecules. Okay? Molecules are formed when 2 or more atoms join together chemically. When they join together chemically, we call that bonding, and we'll talk about that in a couple of minutes. One example shown here is a water molecule. Now, sometimes you'll have seen water abbreviated H2O. And this diagram here shows that you have 2 hydrogen atoms, the capital H, bonded, drawn by a line, with an oxygen atom. So all together, those atoms are bonded, they're stuck together, and together they make up a water molecule. Okay? So a molecule is when you have 2 or more atoms that are joined together. Okay? It could be like H2O, water. It could be 2 oxygen atoms that are bonded together. There are also what are called ions. Ions are charged atoms. They can be either positive or negative. This happens when atoms don't have the same number of protons and electrons. So if you have 5 protons and 6 electrons, that doesn't balance out. It's not going to be 0. So if you had more electrons, you would have a negative charge. And if an atom had more protons, it would have a positive charge. Okay? It's when we don't have the same number of protons and electrons. Now, like I said before, bonding is how molecules are formed, and there are 2 types of bonding that we are going to talk about. They are covalent. First one is covalent, and this involves the sharing of electron pairs. Okay, so electrons get shared between different atoms. So if you look at the example on the right, we've got water, H2O, that we just looked at. And if you count up, okay, there are a total of 1, 2, 3, 4, 5, 6, 7, 8 blue dots there. Those represent our 8 electrons in our oxygen atom. And if you count up what's in the shells, okay, the inner shell has 2, and the outer shell only has 6 blue. It doesn't like that. It wants to be full. Electron shells like to be full. They don't like to just be missing one or just have an extra one. They're not happy with there. So instead, they're sharing from our hydrogen, the H atoms, and if you count, share those ones, we get 8 total in that outer shell. Okay. If you look at the next example, ammonia. Its chemical formula is NH3. And if you look here, the first ring for the nitrogen in the center has 2. It's good. And if you look at the next ring, and you count the blue dots, we have a total of 5. Okay? 5 is an unhappy number. Okay? It wants to have 8. So it shares with 3 hydrogen atoms so that its outer shell is full and happy. Okay. The next example here is CH4 called methane, and this gas gets released when you fart. If you look at the center again, we have 2 blue dots. That center is happy. That first ring is happy. And then if you look on the outside, there's 4 blue, and it wants to share with the other hydrogen ones to fill that up. It wants to get to that total number of 8. This is covalent bonding, where our electrons are shared. The other type of bonding that we are going to talk about is ionic bonding. And this happens when there's a bond that forms between 2 ions. Okay? And they're oppositely charged. So if we look here on the example, we have sodium, Na stands for sodium, and has a +1 charge. Okay? It's got this one little extra sodium electron on its outer shell, and it doesn't like having that. It is not happy. But if you look here, we've got chlorine. Okay? It has a -1 charge, and it doesn't like having this one empty spot. Okay, it's got 7 on the outer ring. It wants to have 8. So in order to get that, these bond together, okay, and we get NaCl, or sodium chloride, which is also known as salt. Okay? So covalent bonding, sharing of electrons, ionic bonding, is when we have ions bonding that are oppositely charged. Okay? One other word for us here, okay, is a compound. Compounds are molecules that contain at least 2 different elements. So a compound has 2 different elements from our periodic table. It might be water, which has both hydrogen and oxygen in it. Okay? All compounds are molecules, but not all molecules are compounds, which sometimes can be hard for students to kind of wrap their mind around at first. But if you look here, okay, we're going to go through and we're going to sort these different examples. Our first example we're going to look at is water. Now water, okay, has more than 1 atom, so it's a molecule, and it also has more than 1 type of atom. It's got both hydrogen and oxygen, so we would move this to both molecule and compound. Okay. The next one I've got is O2 here. This is oxygen gas. It is only made up of oxygen, but it has more than 1 atom, so it is only a molecule. In order to be compounded, have to have another atom or another type of element with it. NaCl, sodium chloride, salt, has 2 different types of elements, so that is a compound. O3 here is ozone. We can find that in the atmosphere in the ozone layer, and that has only oxygen bonded together, so that would be a molecule. Carbon dioxide, compound, because it has different elements. Nitrogen gas would go on molecule. Hydrogen gas would go to molecule. Fe2O3 is iron oxide. Okay, that is a compound. And CO, carbon monoxide, which can be dangerous, would go on to the right because it has 2 different types of elements. Thanks for watching today. We will go through questions in class.